Hi, my name is Jonathan, and welcome to part one of our dynamic routing presentation for SD-WAN. So what we're going to do is compare the underlay versus overlay routing, and we're also going to compare, look at OSPF and BGP. Remember, the underlay is the physical connections between sites, and the overlay is the OMP protocol and the fabric that's running on top of that system. Okay? We're going to use overlay and underlay a lot, so you're going to need to understand the difference between those terms. I'm going to keep mentioning this definition over and over again because it needs to be hammered home. We need to make sure you understand those because those words are used to describe very complex concepts, and I want to make sure we understand them. All right. So we're going to talk about underlay versus overlay routing. So underlay is the connections between sites, and overlay is going to be the OMP. When you see the word overlay, I want you to translate that word into your head and go that in your head to OMP, because that's what we're actually talking about. Okay? And we're talking about the dynamic routing protocols and their best practices. So, as I've said before, and I'm going to say again, the underlay transport network is the physical infrastructure above which the overlay is built. Okay? So if I've got an MPLS connection from a vEdge device into a network, that's my underlay network. If that site connects me to other vEdge sites, I'm going to run an overlay network that's going to create the tunnels between those sites. Okay? Basically, we can connect over any type of transport network. Public internet, MPLS, Metro Ethernet, 4G, point-to-point networks. If it has an IP address on both sides and the IP is pingable, we can build a tunnel to it. Okay? We're going to have some network considerations we need to be concerned with. Okay? Overhead. Packet delivery is going to occur at the network layer, so no additional packet overhead is going to be necessary. Multipath forwarding. We have multiple paths. There's going to be some overhead and complexity, and it is a little less scalable than in the underlying networks. And deployment time. Deploying new services in underlay networks is time-consuming to set up. Remember, if I have to create a connection between site 1 and site 2, 3, and 4, that's going to take a lot of time. But if I have just site 1 connecting to an MPLS environment and into an internet connection, I can use the SD-WAN to create all of those connections dynamically for me. Okay? So the overlay network consideration that we need to take care of, there's a substantial amount of overhead here. Packets have to be encapsulated to form a virtual link between the source and destination. Hence, additional packet overhead is going to be required. Multi-tenancy. We do have the ability to support overlapping IP addresses between multiple tenants on the same network. And multipath forwarding. We do have support for multipath forwarding within the network, and we can deploy this stuff very rapidly. Remember, we don't have to manually configure any of this at all. We can configure each site to connect into the environment, and then we throw on top OMP and the overlay network on top to create all of these virtual links. All right. So just so you're aware, your connection to your MPLS provider isn't going to change. Right? You have a PE, the provider edge, and a CE, the customer edge routers. Those are still connected to each other into your MPLS environment. Okay? And how you're connected, usually BGP, all right, is not going to change. Okay? The type of routing you use is going to depend on that local service provider. A lot of them are BGP, some are just statics, where they'll give you a /30, and you'll have an IP address, and you'll just have that as your default gateway. Okay? But we can use BGP, OSPF, or any even just static routing. If it's the only way of egress, a static route is fine. Generally, when a local site connects to a layer 3 VPN MPLS cloud, the vEdge is going to act as that CE device. So if I have a greenfield location, I'm going to deploy my vEdge as the CE device, my customer edge device. Okay? We're going to talk about in a later slide deck about integrating the two for brownfield deployments where there's already a CE router and that router is providing services that the vEdge can't perform, and we want to retain it. Cisco doesn't advise using router protocols on the transport side. In 99.9% of the cases, you simply use a default route on the WAN edge toward that transport. However, if you have multiple connections, one's internet and one's MPLS without internet, we may want to have separate routing for each of them. Okay? So how does overlay routing work? Well, basically it's going to be controlled by the overlay management protocol, okay, which allows the building of those scalable, dynamic, on-demand and secure IPsec VPNs. Okay? We use a centralized controller for easy orchestration with full policy control that includes that granular access control and scalable secure data plane between all edge nodes. We allow all those edge nodes to communicate directly over any type of transport network. whether the public WAN, internet, metro ethernet, etc., and anything else. And we support BGP and OSPF unicast routing protocols. If you're going to ask, yes, EIGRP is not supported at this time. As I understand it, it is in progress, but I don't have any more information than that. And you can configure all of these protocols on the VH routers to provide the reachability that you need to connect to those sites. So the whole purpose of this is that we want to enable routing on the service side of the network. So remember, we have two sides of the network. We have the underlay and the overlay network, which is between the vEdges, vSmart, and all the other sites. These are where your MPLS, internet, etc. are, right? This is each site connecting. Then we have the services side. Okay? This is where we're providing service. These are the P side we're providing services to. Okay? So if you think of the services side, I want you to think of that's the side that's using this SD-WAN solution. They're the user side of the network, if you will. Okay? And from that side, we can run BGP, OSPF, and statics, and connected routes as well to connect back to the devices, those service-side devices. Okay? To set up routing on those, you provision a VPN or multiple VPNs if segmentation is required. So what we can do is we can have a VPN 1, right? Remember, VPN 1 through 511 are going to be the service-side VPNs. All of this in here is VPN 0. And then this connection is VPN 512. This is getting cluttered. Let me erase some of this. So VPN 512 connects directly to vSmart. VPN 0 connects full mesh to the other sides inside. This is where our internet connection is where our MPLS connections are. VPN 1 through 511 are your service-side networks. Okay? And we can run OSPF, BGP, static, or have connected interfaces there. Okay? So within each VPN, so let's say we have VPN 1 because we're talking about a service-side VPN, right? We assign the interfaces that are on the inside of those devices, so these guys, into that VPN 1 through 511. We can segment those as needed, right? Or we can run routing protocols as needed also to make sure that we propagate routes the way we want to. Okay? So remember, this side of the network, the vSmart side of the network, has no access to what's going on back here. There's actually a strict line of demarcation through the router, through these vEdge devices, from this side of the network to the other. Okay? vSmart only cares about VPN 0 and VPN 512. It does no information on VPN 1 through 511 as far as what's happening back here. Okay? So we bring a route in, all right, and what we're going to do is redistribute it into OMP. And we'll talk about that in the next couple of slides. Okay? So we have three types of routes we're going to talk about. We have OMP routes, TLOC routes, that's transport locator routes, and network service routes, which we're going to talk about in the next couple of slides. All right? So if that looks confusing, we're going to explain it in detail, so don't freak out yet. Okay? So the very first one I want to talk about is OMP routes. These are the routes that are learned from the service side. Okay? So remember, we have on the service side, we have OSPF, BGP, and static and connected routes. What we're going to do is redistribute those into OMP. Okay? Basically, these are all the prefixes we learned from within that certain VPN at the local service side via those routing protocols or static.